Hi guys, so this will be the last video for you guys to do for the snow day. It'll be a short one. I just want to go through these two examples of if you're given a graph, how to write the equation of the quadratic, and we'll write it in both forms. So the easiest form to first get this equation is going to be into vertex form, and then at the very end we'll change that into standard form. So if we are now given a graph, we kind of want to think about it backwards on what would I need to take off this graph to then go back and get it into vertex form. And if you remember, vertex form is always going to look like this. F of x equals a x minus h squared plus k. So the three things that I really need to have this equation in vertex form is I need to know what a is, I need to know what h is, and I need to know what k is. Okay, and the two things I can get right from the graph right off the bat is h and k from the vertex. A will take a little bit more work. So if you look here, we can find our vertex on this graph right here. So our vertex is, I'm going to write it over here, our vertex is the point -1, -6 on this graph. Okay, so we know right off the bat now that our equation would look like this. In order to have that vertex, in order to have it shifted to the left 1 unit means I would have an x plus 1 in my squared, and to go down 6 units I would have minus 6 there. So the only thing right now that I don't know is what a is. Okay, so this a right here is still missing. Okay, everything else I have just from looking at the graph and finding what the vertex is. So to find a, so I really need to figure out, how wide or narrow is this? And I know a should come out positive when I'm done. So that's kind of a good check. So to figure what a is, I'm going to find another point on the graph, find just one other point. You want it to be a nice whole point. And I'm going to plug into my equation. I'm going to plug in for x and y, x and f of x. Okay, so I'm going to find the point, let's see, a nice whole point that we want. And it wouldn't matter if you took one and I took another one, but let's just all do this one right here. You just want to find one that's definitely crossing through a nice whole point. So that point right there is the point 3, 2. Okay, so if I take 3 for x and 2 for f of x and I plug it in, it's going to look like this. So if I take so it's going to look like 2 equals, well, I don't know what a is, but I'm using a 3 for x, so I've got 3 plus 1 squared minus 6. And once I do that, I've got just a one variable equation that I'm going to solve. So I'm going to bring this over here. So I'm going to write the 6 over here. I'm going to bring that over as an 8. And then what I have right here is 4 squared, so I really have 16a right there. So a must be 1/2. Okay, so now I figured out my missing value. A is 1/2. It came out positive, which makes sense because it's opened up. So my equation would look like this now. My finished equation would be f of x equals, I'll put the 1/2 in here, x plus 1, quantity squared, minus 6. So that's my equation in vertex form. If you had to have it in standard form, it would just be a matter of taking your x plus 1 and foiling it out, and then going through with a 1/2 and subtracting the 6. So it would really just be multiplying that out to get into standard form. I don't have any room on here, so rather than kind of mess this all up, I'm just going to leave it in vertex form. If I have time and room on the one below, I'll do it there. So let's try one more. Let's try this one down here that we've got a graph of. Okay, so we do the same thing. The first thing we're going to do is we're going to figure out what our vertex is, and we're going to get started like that. Okay, so this vertex looks like it's, let's see, 1, 2, 3, 3, 5. Okay, so my vertex is right here at the point 3, 5. Okay, so I know so far my equation must look like this. Well, I don't know a yet. So if my graph shifted to the right 3, that must have come from an x minus 3 using those transformations that we did on Tuesday. And if it went up 5 units, it must have had a plus 5 on the end. Okay, so the only thing that we don't know right now is A. Okay, so now we're going to find one other point. Okay, so that's where we are so far. Let's find another point. It's got to be a nice whole point, so I'm going to choose this point right here. Okay, and that is the point for 3. Okay, so now I'm going to plug that in. So I'm going to now take my 4 for x and 3 for f of x. So it's going to look like this. Still don't know what a is. 4 minus 3 quantity squared plus 5. So now we're going to solve this for a. So let's see. First of all, on this time I'll do it over here. I'll do it. I'll fix up this parentheses and square first. So well, this just gives me a 1 squared is 1. So actually all I have there is a plus 5. Okay, so a is negative 2. Okay, so for my full equation is going to look like this now. My finished vertex form of this graph is going to be negative 2 is what we got for a, and then x minus 3 quantity squared plus 5. Okay, so let's just kind of verify that this looks like this kind of graph. So we knew that it shifted over to the right 3 and up 5. Now the negative 2 means it is opening down and somewhat narrow. And if you look at the graph, that matches perfectly, so that makes sense. So there's vertex form. So if we had to have standard form, it's a matter of taking all of that and multiplying it out. So let's do that. Okay, so if I were to take that x minus 3 and raise it to the second power, remember it's x minus 3 times itself, so it's x squared if I were foiling it. I would get a minus 6x in the middle and plus 9 if I were foiling that out. So all of that minus 2 on the outside and plus 5. Okay, so let's distribute. So I get a minus 2x squared plus 12x minus 18 plus 5. Okay, I'm just distributing and combining. So I get minus 2x, oh, it's 2x squared, sorry, plus 12x minus 13. And that would be the same exact equation as above, just in standard form where we'd have a, b, and c. So if you wanted to do, if you were doing this on a quiz and you just want to kind of make sure you were right, if you went and found your vertex on there using the negative b over 2a, you should come out to be that vertex that we got of 3, 5 up in the beginning. And also you can see on this one, my y-intercept is negative 13. And if you look at your graph, you can see it is heading down there, so that it does make sense with my graph. So there we have both forms, vertex and standard form. Any one quadratic can be converted from one to the other form, but when I'm given an equation, or sorry, a graph, the first thing, the easier form for me to write is the vertex form. And after that, it's just a matter of foiling things out and distributing. Okay, so that's going to do it for your videos and for your snow day assignment. So you're going to bring these 3 pages that we filled out between the 3 videos. You're going to bring them all in on next Tuesday, and you're going to show them to me for a quiz grade, and you're going to complete homework section 3.1 by the regular due date of Monday. And then we'll come in on class on Tuesday and do one more example of each of these before we move on, and then we'll get ready for your test as well. Okay, so have a good snow day and enjoy your weekend. Bye.